tell me about all the activities that the human species has engaged in its history. Because, personally, I want to go to Mars, all right? But I'm a little too old, but I want us as a species to go to Mars. That's a side thing I have. You don't have to want to do that too. It's just what I want to do. And I thought to myself, well, that is a place. It's not just an idea, but it's a place plus ideas. There might be life there. We might learn something. There are new discoveries in the new places. So I said, all right, what did people do in the past to engage in expensive projects? Because if we go to Mars, that's going to be expensive. And somebody's going to have to write the check if we did such a thing. Is that even justifiable to do this? Actually, we put the money in the bank and then they write the check. Okay, that's how, we're all family here. That's how that works. All right, so I said, here's what I'm going to do. I'm going to look at all the things humans have done throughout time. Find out what it cost as a fraction of the GDP of the day. And then ask, how much does it cost to go to Mars today? And then line that up in the chart and find out what motivated them to do whatever was this other activity. And maybe we can duplicate that in modern times. That's how we would then engage in major funded projects, I thought to myself. So I thought this would easily fill the chapter talking about ways people were motivated to do great things. I was going to different chapters on all the different ways people justified it. And here's what I found. There were only 3 motivators in the history of human culture. 3 motivators that drove nations and states to do great things. Great as in large, unforgettably magnificent, or unforgettably devastating. Just an investment of human and financial capital. We can make a list of what would go on that list, of what would be there. So the pyramids, that's big and expensive, and they're still around. The pyramids. By the way, do you know the next thing in human culture that was built that was taller than the pyramids? Eiffel Tower. The Eiffel Tower. What was that, 18, right? 5,000 years later, we figured out how to make something taller. Actually, there was a cathedral in the 1400s, but they didn't quite know how to sustain domes, so it was a short-lived. All right, the pyramids would be on there. The Great Wall of China, the Manhattan Project, the Apollo Project, the Columbus voyages. We'd all agree, these are expensive things undertaken by nations. What did they have in common? Only one of 3 things. The greatest driver of them all is obvious. It's the I don't want to die driver, all right? The war driver. That's where you get the Great Wall of China. That's where you get the Manhattan Project. Time and time and again, the conduct of our species has demonstrated that if you feel threatened, money flows like rivers to minimize that threat or eradicate it altogether. No matter the project. There's another driver, the promise of economic return. That's how you get the Columbus voyages and Magellan voyages, Lewis and Clark. You get investments where people say, I don't want to die poor. Okay? There's a third driver there's less of today. Less of it today. Common centuries ago, and that's the praise of royalty or deity. That got you the cathedral building in Europe. Whole episodes where most of the GDP went into building cathedrals. Not most, big chunks of the GDP went into building cathedrals. The pyramids, that's praise of royalty. There's less of that today, hardly any of that today. You don't see whole nations investing huge amount of money in the service of God or their king. It just doesn't happen much anymore. So there are two drivers. Two drivers. If you want to do something expensive and it does not fulfill one of those two drivers, it's not going to happen. Period. Unless you're going to claim that you live in a very special community that differs in its outlook on the causes and effects of investment and human dreams. If you have to say that you are different from every civilization that has come before you. I don't see evidence of that. Three drivers. All right, I'm going to get back to those in a moment. This new caucus that was established, Science and National Labs. Most people never heard of national labs. No offense here, but I think I'm right. All right? What is a national lab? You've probably heard of a few of them. Their names kind of resonate in the 20th century history books. Brookhaven Lab, Lawrence Livermore Labs, Stanford Linear Accelerator. You know, you get these places and you knew some big physics was going on there. It is a community of centers where big research takes place. A lot of them owed their birth to sort of 20th century sort of military. It was like we knew that physicists are experts in matter, motion, and energy. And war is about putting energy that is here, there. That's all it is, okay? If there's a target, you don't want that target to exist anymore, you take the energy that you created here and you put it at the target. That destroys the target. That is war reduced to its most fundamental laws of physics. All right, well, I understand that. You can build centers because you feel threatened. It was a Cold War. Sure, I understand that. Even though I'm an academic, I understand that. Uh, 1989, peace broke out in Europe. We almost had the largest accelerator in the world, superconducting super collider. Started construction on it in Texas in the 1980s. It was the next frontier in physics. If you go in a place in energy that no one has been before, you're going to discover something. It's that simple. Because you're stepping where no one has stepped before. That is exploration in the laboratory. So here we are riding a century of American leadership in particle physics. Do you know the periodic table of elements? If I put the national flag on the box according to what nation discovered each element, there's quite a few there. Most of them are Western European nations. America is strongly represented. But you know where we're best represented? Down at the bottom, the heavy elements. After uranium, neptunium, plutonium, we have californium. We have berkelium, all right? If you discover stuff, you get to name it. What a point of pride that was. Continuing in that tradition, the physicists said, let's keep going. 1989 comes around. By the way, you can analyze this in other ways. I'm not going to stop you. But what I'm going to say is that when peace broke out, it became harder for people to justify, particularly those writing the checks, why you'd be spending this much money on physics anymore. The Soviet Union was gone. Budget got cut to zero. And that knocked out the frontier of particle physics in America. Well, interesting thing about science is that it continues anywhere else in the world. You don't have a monopoly on it. So CERN, this center, that's the French spelling of the European Center for Nuclear Research. But I'm told that in French it spells the word CERN. The Centre Européen Recherche Nucléaire, something like that. Anyhow, they built the Large Hadron Collider, the most powerful particle accelerator in the world, and they discovered the Higgs boson. Page one story, even here. We had American scientists there, by the way, and there are actually significant scientific contributions from scientists based, in fact, at Fermilab, who contributed to that discovery. But that fact got lost. The American contribution to that discovery got lost in the news cycle because it got discovered on European soil. So it just didn't, it's hard to take pride in something that someone else announces in another country. What they discovered was the Higgs boson. You know what that is? It's got a weird name. You know, the Higgs, it's a particle that grants mass. It's a particle whose field grants mass to other particles. In fact, it's been colloquially called the God particle. Because if you hand out mass, you're in charge, all right, of the particle physics. You're like, you're the one. And so the way it hands out mass, I give an analogy. I've heard this given, but I think I've improved on the analogy, but the origin of this example I don't take credit for. If you think of a party in Los Angeles, not in the East Coast, West Coast, Los Angeles party, and it's very crowded, and a really famous person walks into the party. So what happens? Everybody crowds around the famous person. So the famous person then cannot move very quickly through that party. No matter what they're sluggish through that party. They have a very high party mass. And if you're a nobody, by Hollywood standards, then no one will crowd around you and you can just walk freely through the party, unhindered. You have a low party mass. So the Higgs field is like a party in Los Angeles. You either have a high party mass or low party mass. And this is the interaction of the Higgs field with other particles. It's an important discovery. Nobel Prize will probably be given for it. We would have discovered that particle 20 years ago. Our accelerator was 3 times the power of that one. So that would have come out first day. Okay? Turn on the switch, pop, there it is. Higgs boson for you. All right, like a vending machine. Now why do I mention this? Well, war isn't the only driver. Economics is too. It's a huge driver. If we have a suite of centers that previously were in the service of defending the country in some way, because you hire physicists, and physicist is the physics of nuclei that led to the bomb that leads to advanced weaponry, I understand that. But economics matters too. Imagine if you took this suite of national labs and said, the country has needs. The country has, we want to engage in projects that are too big for a university. University is like a professor and maybe a lab. Some things require the government, and it's not immediately lucrative to do it. So corporations, their R&D can't justify it. There's this zone that can only be touched by the government dollar if the government cares about its future. Look at the problems that energy and battery technology and nanotechnology and biofuels and maglev, and you just go down the list. I want a country where you have a lab system where you walk by and say, oh, they're working on solving this problem that still befalls us. That'll feel good. Then you've created the country worth defending. We're not waiting around for some other country to come up with our solutions. by the way, you can't you can't say, okay, I want a more efficient transportation system and I need it in a year and a half. Okay, the engineers will work hard. But somewhere in there, you need the scientists doing the basic research. The kind of research that a corporation can't really justify. Because they've got the quarterly report, they've got the shareholders, and they're looking for the return. And if the return is 40 years from now, they're not investing. But the country is here forever. At least in our minds, we want it to be here forever. So somebody's got to make the investment that goes longer than the time scale of the corporation. So you have the engineers working on the new physics, the new sciences, but you need the science as well. What are some examples of this? In the 1700s, we started to study the concept of heat, energy. In the days of Isaac Newton, my man Isaac Newton, 1600s, the concept of energy was not formulated scientifically. It was not well understood. It would take another century. Then you get like a steam engine, and you start figuring out how to convert energy from one form into another. Mechanical energy, chemical energy, energy of gravity, gravitational potential, and all these forms of energy can be converted into one another with the right machine. Thus was born the Industrial Revolution. And the nations that embraced the Industrial Revolution led the world in every metric that mattered in civilization, mattered to a civilization. So what would next happen? Middle 1800s, Michael Faraday, playing with electricity on a tabletop. He takes a wire and moves it through a magnetic field, and a dial jumps that the wire is connected to. Well, if you do this over here and something else happens over here, that's really intriguing to a physicist. You know, almost like a cat, you know, looking at the laser beam on the floor. You know, the physicist is, you know, it's kind of like a... And people said, Michael, his name is Michael Faraday, what are you doing? What are you wasting government money for? Here's a famous reply to that. He said, sir, because I think it was a member of parliament who came and asked, is this what we're paying you to do, to make these tabletop toys? He says, I don't know of what use this will one day be, but I guarantee you, sir, one day you will tax it. Passing the wire through a magnetic field is how we generate electricity today. It is the foundation of all generators, turbines. Anything that turns creates electricity and something else makes it turn. You're moving wires through magnetic fields. That was in the mid-1800s. We didn't electrify cities until the turn of the century, the early 1900s. It took 50 years for his tabletop experiments in the hands of clever engineers and technologists to transform the world and how we lived. Now you just flick a switch on the wall, all the lights turn on. What intrigues me is that so respectful of that era we are, that our lights even look like candles, you see? So in the back, we still have look at that, right? This is the 21st, you know, and I know this is an old building, but you can buy candelabras with electric candle bulbs in them, right? So, but it took about 50 years. You know what happened in the 1920s? Other than Hubble discovering Hubble the man, there was a guy who came before the telescope, just so we understand. In the 1920s, Hubble discovered that the Milky Way is not the only galaxy in the universe, but billions more, and that the universe is expanding. Cool. But that's not why I'm telling you about the 1920s. The 1920s was the birth of quantum physics. You can't get crazier than quantum physics. oh my gosh, particles pop in and out of existence. You try to measure it and it's not there anymore, but you saw it there a moment ago. And it was intriguing. Once again, it was the physicist following, the bouncing ball. Weird, crazy things were going on inside the atom. Weird things. It's a curiosity. Enlightened nations funded that research. That's the 1920s. 50 years later, we would see the birth of the information technology revolution. Do you realize that, the last time I did a back of the envelope calculation, it was something like a third of the world economy is based on knowledge of quantum physics, because information technology requires quantum physics. In the design, in the creation of data, in the acquisition, the storage, the dissemination of information. That's why it's the IT revolution. It's not a computer revolution. Computers is there. It's all about what we're doing with information. It's no longer on a printed page, here's the information. No. No. I was on the airplane yesterday, and I got a note from a program installed on my father's computer that he's running out of disk space. I then sent an email to my sister's husband, said, check out my father's computer, something's dumping data onto. He goes and checks it out. Oh, there's a program run awry. We fixed it, everything's fine. I said, fine. And I did that while flying 200 miles in distance at 31,000 feet up. That's information moving that requires quantum physics. That was basic science, which at the time, surely there were people who say, what are you doing? I don't understand it. Why? Is that putting food on my plate? Is there some new weapon I can use to defend myself? People were surely asking these questions of quantum physics. But we had people who were curious about the nature of the world, and they pursued it, and they were allowed to by enlightened governments. And now, no part of the modern economy isn't touched by the fruits of the investment that went into those discoveries. This goes on and on and on and on. By the way, and that time delay was 50 years. Not 2 years. You know what I wonder? Maybe there should be a new law. I know we have too many laws, but a new law where every congressional session, what do you call the unit of 2 years in Congress? That's called something. A session, term, every congressional term, you've got to pass a law that enriches, benefits the country on a time scale longer than your re-election time scale. You have to. Wouldn't that be a great law? And that'll say, now we're thinking, I'm not going to be in office then, but I now have to care about tomorrow. Imagine what effect that would have.